Hi, I'm Mr. V. This is Illustrative Mathematics, Unit 2, Congruence, and today we're talking about Lesson 7, which is angle, side angle, triangle congruence, and the angle, side angle, triangle congruence theorem. By the end of the period, you should be able to say, I can explain why the angle, side angle, triangle congruence theorem works, and I can use this triangle congruence theorem in a proof. And we will do both of those. So the first thing we have is this statement. In a previous math class, maybe Algebra 1, you learned that two lines in a plane may intersect once, always, or never. The assertion is that two distinct points is a unique line. So this means that if there is at least one point that belongs to one line and not to another, there are two distinct lines. If more than one point belongs to two lines, the two lines will have all points in common. That is, they'll be the same line. And if two lines have no points in common, then they will be parallel. Therefore, we can conclude, given two distinct lines, they are either parallel or they intersect once. So try doing a drag test. Maybe you move point A. See, oh, these still intersect at one point. Maybe you move it around until they're parallel. And then tell me, what do you notice and what do you wonder? Some things some students noticed was that it's all about lines, defines parallel lines. Two lines that are not the same line are either parallel or they intersect at one point. Why is this important? Why couldn't lines have more than one point in common? Don't ask me. What does unique line mean? Well, this is important because since two distinct lines can meet only at one point, we can use this in writing proofs as justification of why 2 points that are on the same, the 2 points would coincide. And you'll see this later today when we go through a proof. So the first thing we're going to do is proving the angle, side angle, triangle congruence theorem. And we're going to do a visual proof of this. You have two triangles. They have two pairs of corresponding angles that are congruent, and the included side, or the corresponding sides between those two angles are congruent. You're going to use the applet on the next page to create this situation, and then you're going to show me why these two triangles must be congruent with only this limited information, the two angles that are congruent and the included sides. And the triangles are labeled WXY, DEF. Make sure that the angle D is congruent to angle W, angle X is congruent to angle E, and segment WX is congruent to segment DE. I will demonstrate this for you. Here I have two triangles. I'm going to start with the sides. I'm going to make this side, I'll make it 4.5, which means I'll make this side here 4.5, 4.5 if I can make it 4.5. And I'm not going to mess with these 2 points anymore. I'm going to leave them alone because I want this segment to stay 4.5. But I can move this angle around. I'll make this, let's see if I can make it 90. I don't know if I can make it 90 and 21. Why not? So make this one 90 degrees, 90. And now I'm going to go up and down on this line until I get to be 90 degrees, 90, 89, 90. I've got to make this 21. It's not as easy as it looks. Maybe it's harder than you think. But it's something that you can try. Now, if these two are congruent, if this limited information of angle, side angle is enough that the two triangles are congruent, then there's a rigid transformation that will move the one to the other. And I've told you before that if two triangles are congruent, you can always translate them, reflect them, and then rotate them if you need to. Or reflect them if you need to and then rotate. And they will always match up. Here it looks like I can do this with just a translation and a rotation. I'm going to transform this. I'm going to define my translation from W to D. And when I transform this entire set this far, there it is. And for your benefit, I'm going to change the color of this to purple. If I can get this purple to match up with this other one, it'll be fine. I need to know an angle, though. I need to know this angle. I'm going to call this is Y prime DF. That's going to be 16 degrees. So I will define my transformation as a rotation. I'm going to go around this point. I'm going to go 16 degrees, not 90. And I'm going to go in the counterclockwise direction, which means it's going to be just 16 degrees. And when I apply that to this triangle, you can see that it matches up perfectly. Why? This is enough information. So on the next page here, you can tell me what steps you did. You can tell me I translated from W to D. I rotated around point D at so many degrees, or by angle Y prime DE, whatever it was. And then we didn't have to reflect, but if necessary, we could have reflected. And those would be the steps. And it works every time. Well, this is an informal proof. Next, we're going to do a formal proof. This is a formal proof. On this page, we're going to look step by step, and you're supposed to mark your drawing. I'm going to move my thing over here so I can show you what this would look like for me. So here we have step by step as a proof. We're given triangle WXY. Move this over just a little bit. Given WXY, and I'm given DEF, such that angles W and D are congruent. Let's see if I move this over here. Would this help? Yeah, I think so. I can move this to this side. There we go. Now, since W, X, and DE are the same length, marked as the same length, that means that they must be congruent. Therefore, there's a rigid motion that will take DE to EF. Now, let me just move this over, move my picture over, make sure that I'm going to mark this drawing as I would hope that you would mark it at your place when you're doing this. So I'm going to say these two segments are congruent. DE and WX. They're congruent. I'll also make my pen smaller and go to the next step. The next step says, apply this rigid motion to the entire thing. When I apply this rigid motion to the entire thing, I get this. I have W here, Y here, and X here. I also have this angle doesn't change, and this segment is still the same, and this is a double tick mark. At this point, we have 2 points that are lined up. That is, the W matches up with D, and X matches up with E. I need to match this third point up with X and the F and the Y. That's what the rest of the proof is about, is matching those third points up. Let's see how we do it. Next, we say here, we cannot be sure that the image of Y corresponds with F yet. If necessary, reflect this and across DE to make sure that the image of Y, which we will call Y prime, is on the same side of DE. So let me just do that. When I do this, I end up with this right here. And I have my W and X don't change, but this will be Y prime. And all I know so far is that it's on the same side of DE as F is. I'm not sure if they line up yet. We know that the image of angle W is congruent to the angle W is congruent to angle D because rigid motion don't change the sides of angles. Well, this angle W is one tick here, and D is here. And when we move this over, these are the same angle. Yeah, well, I don't have to mark anything there. But the next step says Y prime up here has to be on the ray DF. Why? Because we know it's on the same side of DE because we reflected it, and because it's by the same angle as this angle. So it's on this ray. I don't know yet that it corresponds with F, but I know it's on the same ray. Next step. We know that the image of angle X is congruent to angle E. This blue one is congruent to this blue one. When I move this over, I've still got 2 ticks. These are the same. And then step 7 is Y prime must be on ray EF. I should mark this first one, ray DF. Ray DF is this ray, this purple. I'll do the ray EF. I'll do that in blue. You see, this is the ray EF. Oh. Y prime has to be on ray EF, since it makes the same angle here at E as this angle. So the next step says, therefore, Y prime is on both rays. It's on ray DF and ray EF. But wait a minute. F is already the intersection point of these two rays. Therefore, Y and F must coincide, because when you have 2 lines, remember the bell work, you have 2 lines that intersect, they can only intersect at a point. And since ray DF and EF intersect at this point, when I know that Y is on ray DF and ray EF, where those 2 points intersect, it has to be the same point. This is great because now we have shown that all 3 points, this point and these two intersect or coincide, W with D, X with E, and now Y prime with F. Therefore, the triangles are congruent. And what this is, folks, is a proof of the angle-side-angle triangle congruence theorem. This is a rigorous proof, by the way. This is not trivial. Now, I don't want to have to do this each time. But now that I've proved it, I can use the shortcut. Oh, by the way, think about this information for just a minute. Could this situation be looked like after we reflected across? And how do you know? Well, remember, when we reflected across, we said that y has to be on DF because it's the same angle as this angle. And y has to be on ray EF because it's the same angle as this angle. And so this could never be true, that it's going to be way over here because it's got to be on this ray. Think of it also why the two rays have to intersect at a point. So put this triangle congruence theorem in your pocket or put it in your reference chart, and we will use it now in the proof. Find the missing angles. This is a review of linear pair, vertical pair, alternate exterior, alternate interior angles. A, C, E, and G are all 42. The others would be 180 minus 42, so this would be 138, 138, 138, 138. And I've named them for you already on the previous page. Why? Because when we do this proof about parallelograms, it's going to be important. I'm going to do this proof for you now. If I can move my whiteboard over so I can find this proof. So it says here to sketch parallelogram ABCD. And I've done that on this page. Notice I go in clockwise order. I do not zigzag. I don't go A, B, C, D. You have to do it in either clockwise or counterclockwise order. We know that a parallelogram, by definition, doesn't say anything about the sides. Length. It says about the sides being parallel. Opposite sides are parallel. AB is parallel to CD. I marked that with one arrow. BC is parallel to AD. And I chose to draw the auxiliary line to make these two triangles by connecting points B and D. Now, let's do the proof. I'm going to write this proof out so that you can see it. And we have here step one. First of all, I don't know any of the sides. I only know one of the sides is congruent to itself. I don't know any of these side lengths. So maybe I can use my angle-side-angle triangle congruence theorem that we proved today to do this. Do I find any angles that are congruent? What angle is congruent to this one? Oh, it would be here. Why? Because when you have parallel lines and you have a transversal that crosses them, alternate interior angles are congruent. So my step one, and I'm going to call this, instead of calling it CBD and ABD, I'll call this angle 1, this angle 2. I have angle 1 is congruent to angle 2. And what is my reason? Well, these are alternate interior angles formed by a transversal crossing parallel lines. The alternate interior angles theorem says if a transversal crosses parallel lines, which lines are parallel that I'm talking about? I'm talking about BC is parallel to AD. These are congruent because the transversal crosses parallel lines to form congruent alternate interior angles. That's one angle, one pair of angles that's congruent. If I'm going to use angle side angle, I know this side is congruent to itself. So I could say that BD is congruent to segment DB. Excuse me just a moment. All right. Why? Because it's a common side, or same side if you want to call it that. Common side. We could say that these are congruent because it's the reflexive property. That's the technical name for it. And if you want to use the big boy language, you would say reflexive property. But you could also say common side. I'm fine with that. Common reflexive property. Wait a minute. That's one side with one triangle and one side with the other triangle. So I have angle side. There is no angle side shortcut. I need another angle. Well, I have another angle. I have this angle. It's congruent to this one. When I have a transversal crosses parallel lines, which parallel lines? These lines that are parallel. Here's my transversal. The alternate interior angles are congruent. So I have angle, let's call this angle 3 and angle 4. Why not? Angle 3 is congruent to angle 4 because they're alternate interior angles formed by a transversal crossing which parallel lines? Parallel lines AB, which is parallel to DC. This is my angle side angle. So now, all these interruptions, oh my goodness. So now I can say that the triangles are congruent. Triangle, let's see, 1 tick, 2 ticks, no ticks. That's B, D, C is congruent. I have to match up my angles, remember? So this is 1 tick, 2 ticks, no ticks, D, B, A. Why? Well, it's because of the angle side angle. Triangle congruence theorem. I've proved that before, and now we're using it in another proof to prove something else. Step 5 says that the sides are congruent. Which sides? I'm going to say this side is congruent to this side. So AB is congruent to CD. CD. Why? CD. These are congruent. Because if I prove by the shortcut that the triangles are congruent, then I can say that all the corresponding parts of the congruent triangles are congruent. Huh. That's cool. I could have also said that these two sides are congruent. And I have a video in my lesson plan for you to see that you can actually watch this. Watch it all take place. Here's the video. You can add this to your reference chart. And we'll skip the more for now. Lesson synthesis. What types of things do you need for proof? Well, if you can draw auxiliary lines, you can look for congruent triangles. You need the right 3 pieces to prove the triangles are congruent. You can use the marks on the drawing, or you can use the given information. You can also use other information like your knowledge about parallel lines and transversals. And you can use the corresponding parts to prove corresponding segments of angles are congruent, that they're not listed in when you use the shortcut. So you can use CP/CTC after proving the triangles are congruent. Please read the lesson summary, and then the cool down is when we prove that the both parallel sides are congruent. Good luck and success.